Hi guys, this is Lisa Knight, and I just wanted to give you some feedback. I just graded Module 3. Wanted to apologize for the grading. It was a little bit later than I usually do it, but I had a nasty stomach bug. First thing I want to talk about is I just want to remind you what I mean by finding the polar direction of a vector. Remember that in math, when you learned about polar directions, that is an angle that's measured with respect to the east axis. So anything that's pointing east is at 0 degrees, anything that's north is 90 degrees, west is 180 degrees, and south is 270 degrees. And so if I wanted to measure something that was heading 60 degrees north of east, that would be a vector that's going in this direction here. So when you are charged with making sure that the angle that you're finding is a polar angle, you need to know what quadrant you're in. So you're going to use tan theta, which is y over x, and you're going to use inverse tan theta of y over x. So in this particular example, it's going to the west and then down to the south. So you have a negative x and a negative y. That tells me that I'm in the third quadrant. So my polar angle, if I go back to this, my polar angle down here would be all the way past west down to that angle that I'm finding. And that means that whatever angle I find with tan theta, I have to add 182. So when you're in the third quadrant, when you find the angle, you add 180. When you're in the second quadrant, you subtract off the angle from 180. When you're in the fourth quadrant, you add it to 270. Oh, excuse me, wrong question, wrong way. You subtract it off of 360. When you're in the first quadrant, you just leave it the B. So in question 2, you could have just left it as 8.5 degrees, which would have told me that it was north of east. So in this case, it would be opposite over adjacent, 5 over 10, which is 0.5. To get the angle, I take the inverse tan, make sure that your calculator is in degree mode, and that gives me an angle of 26 degrees. So this little angle is 26 degrees below the west axis. So to make that my polar heading, I'm just going to add 180 to it because I'm in the third quadrant. If it had been 26 degrees in the second quadrant, I would have subtracted 26 off of 180. And then in homework 2, the problem actually asked you what way would the plane have to head in order to go north. So if he tries to go north, let's look at the black arrows. If he tries to go north, he's going to get pushed to the west and end up going west of north. So in order to go north, he has to head exactly the same degrees that he's going to get pushed off course, but east of north, and then the westward wind will push him so that he's going north. So a lot of you found this angle right here, and you found it to be 8.5 degrees, and you called it north of west. But what it needs to be, and that was a wrong description, this little angle would have been west of north. What it needed to be was east of north. Okay, so you needed to give this angle here, or you could have just left it as 8.5 degrees. Well, that would have been fine too. When you got down to the projectile problems, number 5, I think you guys are missing some of the basic understanding that when you throw something up in an angle, that you give it a forward motion and an upward motion. And that forward motion, because there's no other forces acting in the x direction, that forward speed is always going to be the same. So the way that you find that speed is you actually you find that speed using by finding a component, right? Vx is going to be equal to the speed that it's launched at times cosine of whatever the angle is that it's launched at. So in the case of our problem, it would be 200 times cosine of 30, which ends up being 173 meters per second. Vy is going to be a little different. Okay, Vy, you're going to do the same thing, but you're going to use sine instead. And if you do that, you'll get a Vy equal to 200 times sine of 30, which is going to give you 100 meters per second. So you launch it forward at 173 meters per second and upward at 100 meters per second. As it goes up, the Vy is going to reduce by about 9.8 meters per second every second until when you get up to the very top, Vy is 0. And Vx is the same Vx it always has been because it's not accelerating. It's 173 meters per second. And then as it falls, it's going to be Vy is going to be getting bigger, and when it gets down to the very place, same location, or excuse me, height that it was launched at, it has a negative speed of 100 meters per second. So this Vy here was negative 100 meters per second, and Vx was 173. So this is not a mystery. You just had to make a calculation to begin with, and then you're just looking at the symmetry of these problems. And then you should have found out or realized that it does not accelerate in the x direction, but it does accelerate at negative 9.8 meters per second every second in the y direction. And when it came time to find the height, well, this is going to behave like something that was thrown upwards at 100 meters per second, which was the exact problem that most of you calculated correctly in number 4. So I knew that its initial speed was 100 meters per second, right? And I knew that at the top, its speed is 0. So if I'm looking for its height, I don't need to go all the way to where it lands. I just need to go from where it starts to the top, its height. And then I would use a formula that has the initial V, the final V, G, and H in it, or Y. And that would be this one right here. In other words, no time. We don't have any time here. So I would use this formula right here, and I would plug in 0 squared equals 100 squared plus 2 times negative 9.8, and then solve for y. For finding the time, right, I want to know the whole time that it's in the air. And this, most people knew that it started out 100 meters per second, but what you guys made mistakes with is you guys forgot that right before it hits the land, we're not talking about after it hits the land, we're talking about right before it hits the land, it has a velocity of negative 100 meters per second. And then instead of finding height, we would be finding time, t, and so that would mean that we would need something that doesn't have a distance in it, and that would be this formula here. So that would be negative 100 equals 100 plus negative 9.8 times t, and you should have gotten a t of 20.4 seconds. And then to find the range is easy because the range is just its horizontal speed times the time that it's in the air because it's not accelerating, right? It's not accelerating at all. So you don't have to worry about finding A because in the x direction it's not. It would just be delta x would just be your Vx times your time. The biggest mistake that you guys made is when you went to find your time, you evaluated it from 100 to 0 instead of 100 to negative 100. You assumed it just stopped moving when it landed, and it specifically said just before it lands. And the other biggest mistake you had was that when you went to use these formulas, period, you used the 200 meters per second. Now the 200 meters per second doesn't make any sense, right? Because that's not the velocity that's accelerating. The velocity that accelerates are the Vy's. So you need to be looking at the change in Vy. Your V naught and your V, or your V initial or V final, or your Vy initial and your Vy final. And the last thing I want to talk about is your lab. So I've realized that the answers to these Vernier Video Analysis Labs sheets are on the web, and it is easy to get them. And so, to verify and to ensure that you guys are doing your own authentic work, I will post a video telling you what I expect you to do to that lab, and something will be a little bit different than the lab instructions. So, in this lab, I posted that video. I posted it last week. I told you to make sure that you watched it. Um, and I asked you that when you labeled your diagram with the Vx and the Vy vectors as instructed, then I wanted you to actually calculate these, and I actually went through links to show you how to calculate these vectors. So that we would have those calculated, so that when you were asked, is it accelerating in the x direction, you can say no, it's always the same, it's 1.5 meters per second. And is it accelerating in the y direction? Well, at first it's not, because it's rolling on a flat surface. But as it falls, the vectors get longer and longer, and this is indicated by the speeds as well that I calculated. So, so if you did not follow that part of the lab, you did get 10 points. But if you didn't do any of this at all, then you didn't get, you only made a 50 on the lab. This was the main gist of the lab, and you needed to make sure that you had at least drawn your vector diagrams for sure. And if you didn't do that, then you weren't doing the lab as it told you to do it. All right. Most of you are doing okay, but I'm wanting you guys to really focus this time on reading and doing the practice problems. So instead of having a worksheet to do this time, you do have a self-check to do. Um, it is strongly advised that you go through the reading and you do the practice problems in the reading in OpenStax Tutor, and then you go and do the self-check for a grade. And that will be your homework grade this time. So when you post this initial week in your discussion, you should have at least gone through the reading and done the practice reading problems. Some of you guys are saying, oh, I'm doing fine in the reading, I get the problems right. And then when I go and check, you haven't even done your reading. Because I know if you've done your reading in OpenStax Tutor, it tells me how far you've gotten and tells me what your answers were and how many times you attempted it. And then when it comes to doing your homework, some of you guys are failing. There's just a couple of you that are really in trouble, and I'm worried about you. The discussion is meant for you to ask me questions and to get responses and get help and get suggestions on where to go to get more information. So please take advantage of that and make sure that number one, that you make the initial post when you are instructed to do the initial post by. And number two, that you do respond to two other classmates on 2 other days. So that means that you should have a total of 3 posts on 3 separate days in order to get full credit. Please let me know if you're having problems or if you need some help, and I'll be glad to get up with you via online or in my office. Have a great week.